Okay. Um. Yeah, we talk about algebraic expressions. All right. In the usual want to talk we'll talk about um the definition. What are the algebraic expressions? Okay, directly we say that algebraic expression is the use of letters like number, treating letters like numbers. So that is what we mean by algebraic expression. We say treating letters and all symbols like numbers to treat letters and treating letters or symbols like number. Let us look at letters. We have letters like X, C, like I, like C, like I, B, C, etc. And we have symbols like star. That is a symbol. We have pi. It is a symbol. We have a lot of symbols. We have this one is a symbol. We have rho. We have theta. Uh, Symbols. Most of the symbols are Greek symbols and they mean a lot. For example, this stands for angle, this is for density, this is for current, things like those. So, but let us go back to our meaning here. Letters or symbols, use them, treating them like numbers. In mathematics, when we treat things, we normally mean this. We normally mean it or putting putting them into action, like adding them, subtracting them, dividing them, and multiplying them. This is what we mean, and this is our operations in mathematics. We operate numbers. For example, we can say 1 plus 1. Now you see we have used this to operate. This is equal to 2. We can say 2 minus 1. This is equal to 1. Things like those. Now, how can we treat symbols like numbers? Now, so it comes into our heads something like this, like adding now a plus a, k plus b plus c. So what are these? Can we do this? Can we do this? Yes, we can. Yes, we can. So if, for example, we talk now, let us talk about fruits. If we talk, if we have, yeah, I'll say yes, we can. So if we have, let us talk about fruits. We talk about fruits like oranges. If I have two oranges, and we have three uh, buyer, they have five pineapples, and now ask say, yeah, we are talking about this. If we write, if we write these in letters, if we write the oranges, oranges, in that, suppose we choose that we are going to represent oranges by G, for example, one of the letters, and we are going to represent papaya by P, and we are going to represent pineapple by N. So we have five of them here, we have two of them here, and it could be better if I could have used a different color just to make things much. No, blue is good. So we have two here. These are R. We have three here, but these are P. And then we have 5 here, and we give them N. These are N. Okay. So N, we say R represent oranges. P represent papaya, and N represent pineapples. Okay, so if that is the case, then we see how we can treat these things like the way we treat numbers. So I am here first time. Okay, so here we have two oranges. Okay, so we have 2R, and then we have 3 papaya, and we have 5 pineapples. So this is the same as saying we have R plus R, and this is the same as P plus another P, but this is the same as N plus N plus N plus N plus N. So you see, this is R plus R. It gave us 2 oranges. Now this is 10 for oranges, so it is 2 oranges, 2 oranges, 3 papaya, 3 papaya. Now it is papaya plus another one, so we have 3 papaya. Then 5 pineapples, 5 pineapples. So we have 5 pineapples. So you see that these letters here have been treated like numbers. We've treated these like numbers. We have added them the way we do add numbers. So we'll say R, P, and N are treated like numbers. Okay, and we say that R plus R, P plus another P, and these N plus N plus N plus N 5 times, these are called the algebraic expressions. They express algebra. So they're algebraic expressions. So this is what we mean by algebraic expressions, using or treating letters like number. The algebraic expression. There is no equal anywhere. So it's just an expression, a simple expression, which use letters like numbers. P, R plus R, P plus P plus P. So these are very simple algebraic expressions, and that's what we mean by algebraic expressions. So I would like to talk more a bit about these things. We are there. The same way we treated these letters, we can also treat we can also treat symbols. We had stars and whatever. We can treat them like this. If I have stars and other things, the way we showed him. But now I would like to talk about these R, P, and N. They are letters. We call them letters, but in mathematics we call them because not always when you see R, it is going to represent the orange. Not always this P is going to represent papaya. Not always this N is going to represent pineapple. It can represent anything else. So we call these letters, we call them variables. We call them variables because they can change. I mean, they can represent different things. So these are variables. We call them variables. So a variable can take any value. It can take any value. That's what we call a variable. A letter which can take any value, we call it a variable. So we say that these letters we use here are called variables because they can take uh, any value. So those are variable. Now we now know what are variables. Now let us talk a bit about variables. What is a variable? Why should we say it can take a different value? Now suppose we have suppose we talk about tips. Yeah, we can talk about tips. Suppose we talk about the wage of somebody. Juma works Juma works in a hotel. He works in a hotel where he's paid 1,000 shillings per hour. He's paid 1,000 shillings per hour. But he also get tips. So in every hour is paid. So the salary or the wage of Juma in 1 hour will be what he is paid plus the tips. Now let us call the tips T plus the tips he get. Okay, so these tips, I said it's a variable. Now we know they are tips, but we don't know exactly what amount of tip he is given. So we'll find that it is a variable because it can change. It can take any value. Now in this case here, this tip stands for some money. So, but we cannot say it is 20 shillings. It is 40. So maybe this tip at time t can be 500, can be 100, can be 50, sometimes can be even 1,000, just like the salaries. Depends on how the customers flow and the will of the customer to give a tip. So this is money and it is a variable. It is a variable because it changes. You see here, it changes. So the amount changes according to who goes in. And sometimes you cannot get anything, but it changes. So this amount of money paid here will depend on the type of customers going in and also the hours, or I mean if this is a peak hour or this is a low. It's not a peak hour. So we have peak hours, for example, during afternoon when people are going to eat a lot, but sometimes they are between 3 to 4 people are not going to eat, so that the amount of the tip will decrease. So that's how. Okay, so that is all about variables. I mean about the algebraic expression and variable. Now this also is an algebraic expression. This one here is algebraic expression. So yeah, hope you understand, and please be with me in the next tutorial. Thank you for watching.